Hello everyone, welcome to EnviroPioneers. In this video, we will learn about the sound propagation in a closed space and an open space, that is referred as the indoor and outdoor sound propagation. So we will start with the indoor sound propagation. So the main difference between indoor and outdoor sound propagation is in the amount of the reflected sound, because when we talk about the indoor, it is mainly an enclosed room where we have many reflective surfaces. It can be walls, it can be ceiling, it can be floor, or any other material which is placed inside a room. So the indoor environment, it creates more reflective sound than the outdoor environment, because the sound waves, these bounce off the walls of the room or from the materials which are placed there. So within a particular room, the receiver or the person will be hearing direct sound as well as the reflected sound. So this we have already discussed about the direct sound, reverberant sound, near field and the more distant field in the last topic, that was the acoustic field. And the amount of reflection in a particular room or in a building, it depends on the shape and the size of the room. So the room, it may be square, it may be rectangular, it may be a small room, it may be a large room. So depending upon the shape and size of the room, the amount of reflection, it will vary. But by designing the irregular shape of the room or varying ceiling height, it can help us in diffusing the sound and reducing the echoes. And the reflection also depends upon the materials which are used in the construction of the room or the building, because different materials, they have the varying ability to absorb or reflect the sound. Soft materials like the carpets, curtains and the furniture, they have the tendency to absorb the sound waves, while the hard surfaces like the concrete, glass and the wood, they reflect the sound. So here we have three representation. This is the hard surface. So sound waves which are incident on this surface, they are getting reflected off. Then second representation, here we have a material which is absorbing the sound waves. So we can see the amount of reflection is very less. Third representation is of a diffuser or a diffusing surface, where the sound waves, when incident on it, it gets reflected in all the directions. Next is the presence of sound absorbing surfaces. These also control the amount of reflection inside a room. So if the sound absorbing materials like the acoustic panels, ceiling tiles or carpets are used inside a room, it helps in reducing the reverberation and also improve the sound clarity. So these are the acoustic panels. Here we have the ceiling tiles, and here we can see this is the textured loop pile carpet, and here we have the hard flooring. So the sound waves which are incident on the hard floor, they are getting reflected, while the one which is incident on this carpet, they are getting absorbed. The surfaces inside a room can be classified into three categories: acoustically reflective surface, acoustically absorbing surface and acoustically diffusing surface. So when we are using the term acoustically, it means we are talking in reference to the sound waves. तो जो भी surface which are reflecting the sound waves, they are considered as the acoustically reflective surface. Here all of the sound waves are getting bounced off, and the examples are the wallboard and the wood. And the surfaces where some of the sound waves are absorbed, they are considered as the acoustically absorbing surface. Examples are the curtains and the carpet. And the surface where the sound waves are diffused, they are considered as the acoustically diffusing surfaces. And the examples are the bookcases, acoustic panel. Depending upon the size of the room, the type of materials which are placed inside a room, and how this particular room is designed, the amount of reflection may vary. For example, here we have this on the left hand side, we have the bare wall. So the sound waves which are getting incident on this bare wall, they will be getting reflected. While the on the right hand side, here we have the absorber. So the sound waves falling on it, they will get absorbed. So this absorber, it removes the wall reflection. And on the back side, we have a diffuser which scatters the sound waves in all the direction. So if we are having a television or any sound source here, so the person will be receiving the direct sound, some of the reflected sound, and some of the diffused sound. So the sound quality, it may vary depending upon the amount of reflection inside a room. Acoustically absorbing surfaces, they absorb the sound waves of a particular frequency. So, the sound absorbing property of any material, it is described as the sound absorption coefficient in a particular frequency range. So, this coefficient, it is considered as the percentage of the absorbed sound, and it varies from 0 to 1, where 1 is for the complete absorption. It represents that the sound waves is 100% absorbed, and 0.01 is the minimal absorption, which represent that only 1% of the incident sound waves is absorbed. The most effective sound absorbing materials are those having the coefficient towards 1 and absorption towards 100%, and they are suitable for the acoustic treatment for the music studios, home theaters, or listening rooms or offices. The amount of reflection inside a room also depends on the presence of the sound reflecting surfaces. So the reflective surface, it can be strategically placed to enhance the sound in certain areas while avoiding the excessive echoes. So we can see here we have the diffusers or the reflectors which are placed in such a manner that whatever sound is generated on this stage, it is getting reflected towards the audience. So in designing the amphitheater, seminar hall or the lecture room, all these parameters are considered so that the person who is sitting in the back row is hearing the same quality of speech as the person sitting in the front row. So in these rooms, we have the proper architectural designs of the stage, walls, ceilings and the floors, and the proper placement of the sound reflecting surfaces and the sound absorbing materials. जब हम indoor environment में या closed space में sound propagation की study करते हैं, then in that case reverberation time is very important. So this reverberation time is a measure which is used to quantify the reflection of the sound waves. So if we see here in this diagram, if a sound is generated from any source, तो इसका कुछ एक certain sound level होगा, एंड अगर हम उस साउंड सोर्स को स्टॉप कर दें तो आफ्टर मल्टीपल रिफ्लेक्शन दिस साउंड की जो इंटेंसिटी है दैट विल डिके. तो कितने टाइम के बाद ये साउंड इंटेंसिटी 60 डेसिबल कम हो रही है उसको हम कहते हैं रिवर्बरेशन टाइम. So the reverberation time is defined as the time which is required for the sound reflections to decay by 60 decibel after the sound source stops. Means it is no longer audible and is lost in the space. And this reverberation time is directly proportional to the volume of the room and indirectly proportional to the amount of sound absorbing material. So अगर कोई रूम बड़ा है एंड उसमें जो साउंड एब्जॉर्बिंग मटेरियल्स हैं उनका क्वांटिटी कम है, then in that case there will be more reflection of the sound waves and longer will be the reverberation time. Reverberation, it results from multiple sound reflection within a space, and the reverberation time can be calculated using the Seben's formula for a room having the uniform dimension. So the formula is 0.161 into volume of the room in the cubic meters divided by the total absorption area of the room in square meters. So this reverberation time is the measure of the reverberant sound field in a room, and it can most easily reduced by using the acoustic treatment because it is indirectly proportional to the amount of absorbing materials inside the room. So if we have more number of the absorbing materials, we'll be having the less reverberation time. So different rooms, they have the different reverberation time depending upon the size, shape and the surface materials inside the room. And excessive reverberation, it affects the sound intelligibility, while too little reverberation, it reduces the perception of the naturalness of the sound. So in general, a reverberation time of less than 1 second is considered good for the speech intelligibility. while a reverberation time of 1 to 2 seconds is considered good for the music. If we have two rooms, a small empty room and other a large space which is filled with the furniture and other dense objects. So if we compare these two, the small empty room will amplify the sound more in comparison to this one. On the other hand, if we are having a larger room, it provides more space for the sound to travel between the walls and it leads to more echoes. So there is a term fluttering echo, which is a type of repetitive sound reflection which occurs where the sound moves back and forth between the two parallel surfaces and it produces a quick succession of echoes that sounds like a flutter or a buzzing effect. Fluttering echo, it mainly occurs inside the rectangular room with the hard floors, ceilings and the walls. It may happen in the empty rooms with the minimum sound absorption, hallways or the corridors with the bare walls, or in the recording studios, lecture halls or the home theaters if they are not acoustically treated. So wherever we have two parallel walls, the chances of fluttering echo, it increases, and it is different from the reverberation because here after reflection the sound is heard as the second sound, but it is very fast and the quick succession of echoes, and in this case the decrease in the sound intensity is much slower in comparison to the reflection from other normal surfaces. Have you ever experienced that even after closing the doors and windows of the room, you are still able to hear the sounds of the nearby room? So that may occur because of the flanking transmission. When a sound generated inside a room during its propagation encounters any obstacles such as the wall, it can travel through this wall in two ways, either directly passing through this wall, which is referred as the direct transmission, or it can select the alternate path to reach the other side. And these alternate paths can include the gaps, cracks, cavities, plumbing or ventilation system in the room, or the electrical outlet boxes or any other opening in the structure. So this flanking sound or the flanking transmission, it generally refers to the sound that travel around or bypasses any barriers such as the wall, floor or ceilings. So here we can see in this image that the sound which is generated in this room, it is transmitted through the wall, and alternatively it can be transmitted via the ceiling surfaces or via the floor surfaces. And within each transmission we can see three different type of passage. One is represented by the red color, one is represented by the blue color, and the third one is represented as the green color. So it can take alternate pathway to reach into the adjacent room. Suppose if the sound is generated inside this room because of this television, so this sound, it can travel into the adjacent room via the direct transmission or the flanking transmission. Suppose if we have the soundproof wall between these two rooms or the ceiling tiles or the carpets at the floor, then they will reduce the direct transmission. But even after having the soundproofing for a particular room, flanking transmission may occur if the sound waves travel through the gaps around the windows, doors, vents or other structural elements attached to the wall, and this become noticeable on the other side of the wall, floor or the ceiling. These were all for the indoor sound propagation. We will continue with the outdoor sound propagation in the next video. Best wishes and thank you.